And is my screen visible to all?
Yes.
Yes. Yes.
So today we will discuss a very basic topic, that is HCF and LCM, about the HCF and LCM. Anyone of you know about what is HCF and what is LCM?
Highest common
Yeah.
factor, it's like the so it's like the greatest factor that divides some numbers.
Okay, and what
It is
about
common
LCM?
factor or lowest common factor? Lowest common
Highest
factor.
common factor
Lowest
and
common
the
multiple.
lowest common multiple.
Lowest common multiple, yes.
Okay, so
Least common multiple, highest common factor.
okay, let's first understand about HCF. There are several names for this: HCF, GCD, and GCF. Highest common factor, greatest common divisor, and greatest common factor. Right? First of all, this is always positive. This can't be negative, right? First thing. And for example, if I ask the HCF of this is how I will define this. The HCF of two are more non-zero integer is the largest positive integer that divides the number without leaving a remainder. Without leaving a remainder. For example, we have two numbers, 12 and 16. So how can we find the HCF of these? First of all, we need to prime factorize these, both of these. So for 12, this is 2 into 6, and 6 will be 2 into 3. So this will be 2 square into 3, right, for 312. And for 16, that will be 2, 8. Now 8 will be 2, 4, and 4 will be 2 into 2. So this will be 2 power 4. For HCF, just remember one thing. Just take the lowest power. For example, this is 2 power 4 and this is 2 cube, 2 square 3. Just take the lowest power of the common term. That is 2 square, which is common in both, and it's the lowest term. That is 2 square. The HCF of this is 4. For HCF, just consider a common term which is having the lowest power. For example, let's suppose we have 2 square, 1 is 2 cube, and 1 is 2, 4. The HCF will be 2 square, right? Okay, like take any other example. 1 is 18 and 1 is 24. If you prime factorize this, this will be 3 square into 2, right? And this will be 2 cube into 3, right? So what is the lowest power of 3 in both? Which is 1. And what is the lowest power of 2 in both? This is 1, right? So the HCF of this is 6, right?
I have a question.
Yes.
So we have to take the common, we have to take the lowest power of the common numbers. Is that so?
Yes.
Okay.
Yes, exactly. Right? Okay. Now we will discuss that how such questions are asked in exam about the HCF. Now first discuss about LCM. Right? This is least common multiple, and least common multiple of two integers. Let's suppose we have two integers a and b. Let me add one person. Okay, is the smallest integer that is the multiple of both a and b. Okay, and that multiple is evenly divided by a and b. For example, take same case, we have 12 and 16. If you prime factorize 12, the result is 2 square into 3, right? And if you prime factorize 16, the result is 2 power 4. Now, can anyone tell what is the LCM of these?
Two power 4 into 3.
2 square into 2 is 3.
No.
2 power 4
For
into 3.
LCM,
4 into 3.
just consider the highest power in these. The highest power is 2 power 4, and there is only one 3, right? 3. So this is 2 power 3, 16 into 3, that is 48. Now, if you divide 48 by 12 or 16, that is evenly divided and there is no remainder in that. So you got a difference between LCM and HCF. Take some other example. One more example, just for the sort of discussion. Let's suppose we have 12 and we have 24, right? This is 2 square into 3, and this is 2 cube into 3, right? So what will be the LCM? Just see the highest power of 2, that is 2 power 3, and highest power of 1, that is same as this will be 8 into 3, which is 24, right? If you divide 24 with 12 or 24, there will be no remainder, and it is evenly divided, right? This is in case of integer. But let's suppose if the same question is asked for a fraction. For example, if I ask you to find HCF of HCF of 2, 5, and 3, 4, can any one of you tell what will be the answer? What will be the HCF of these two? Anyone?
HCF of 2 and 3 and LCM of 5 and 4.
Yes. In case of fraction, first generalize this. Let's suppose we have two fractions, A, B, and C, D. If you're asked to find about the find the HCF, that will be the HCF of above two, HCF of numerators A and C, divided by LCM of denominators. And in case of LCM, for same A and B and C over D, that will be LCM of numerators A and C and HCF of denominator B and A. For example, yeah, B and D. Okay. For example, we have 2, 5, and 3 over 4. If I find the LCM of this, I will take the LCM of above 2, 2 and 3, and the HCF of below 5 and 4, right? So LCM of 2 and 3 is straightforward 2, 1 into 3, 1, that is 6. Now, can anyone of you tell what is the HCF of 5 and 4?
1.
1.
Yes. These are basically coprimes. I will discuss a bit further what are coprime. Two consecutive integers are coprimes, and there is no common factor between them other than 1. And this is 1. So in this case, the LCM is 6. If I ask to find the HCF of same, what will be the HCF? HCF of 2, 3, and LCM of 5, 4. HCF of 2, 3 is 1, and LCM of 5, 4 is 20, right? 1 by 20.
Right.
Some properties of, not properties, but some facts regarding these HCF and LCM. The first one is the product of, let's suppose two number, your two number, their product is equal to LCM into HCF of that number. Just remember this, we will solve question regarding this. The product of two number will be equal to the product of their LCM and their HCF, right? And the next one is about coprimes. Two consecutive integers are coprimes. Two prime numbers are coprimes to each other. We have 2, 3, or 2 or 5 because there is no factor other than one factor between them. That's why they are called coprimes. And if you have two consecutive number 2, 3, 4, 5, 6, 7, there is no common factor between them other than one. That's why these are called coprime. In case of coprime,
Coprime same as prime number?
no, coprime.
No.
Prime number is different thing. Coprime is, let's suppose there are two numbers, there are two integers, and there is no common factor between them other than one. These could be
Suppose 15.
2 and 5.
Suppose
These could be 15
like,
and 16 in a row.
Yes. 16. Yes.
Doesn't matter. But the property is, for these, HCF will always be equal to 1 and LCM will be equal to the product of these two numbers. Right? Their HCF is 1 and their LCM is 10. Their HCF is 1 and their LCM is just product of 15 and 16. Right?
Yes.
Okay,
Yes.
so
Yes.
let's have a very simple question regarding this. The question says that if X and Y are positive integers and their LCM is Z. So which are the following can never be the value of Z? Right? We have two integers, X and Y, remember positive integers, and their LCM is Z. The question is, which are the following can never be a value of Z, right? So we have three options. One is X, one is X minus Y, and one is XY. Just try to solve this question. You have just 1.5 minutes to solve this question.
Option B.
Option B.
Okay, one is
Yes,
X minus Y.
B.
Option B.
Follow with option B.
Yes.
Yes, the answer is option B. Okay, we have just discussed that the product of the numbers is equal to their LCM and HCF, right? So this means that XY could be greater than or equal to LCM. In case HCF is 1, XY is equal to LCM.
Equal to same.
If case HCF is greater than 1, then X into Y is greater than the LCM, right? Now, if we see first scenario, in case takes X is equal to Y is equal to, take some other value. X is equal to 2 and Y is equal to 1, right? So their LCM will be 2. So Z is equal to X. This is possible. Now, let's suppose X is equal to 3, Y is equal to 4. So what will be LCM of this?
Yeah.
12.
So in this case, Z is equal to XY. but there is no such value in which z is equal to x minus y. Take any value. Okay, for example, did you check any value for this? Hello. Am I audible?
LCM never be negative. Okay, but in case of the third example, that means when x equal to 3, y equal to 4, we get x minus y equal to minus 1. But LCM never be minus 1. Okay, so we can't take this.
Yes, this could be the logic. Okay, so this is a very basic example. Now let's have one more example for this. Okay, so let's have example. We have, the question is that the HCF of x and 15 is equal to 3 and HCF of x and 140 is equal to 14. The question says which of the following could be the HCF of x and 660. The options are 22, B is 30, C is 33, D is 44, and E is 66. I repeat the question. The HCF of x and 15 is 3. The HCF of x and 140 is 14. And the question says which of the following could be the HCF of x and 660. Just solve this question now.
Only one answer?
Yes, only one answer.
B.
Okay, so one answer is B. Any other answer? No other answer. Shall I solve now?
E.
E. Okay. Okay, let's solve this now. The question is saying that HCF of x and 15 is 3. Okay, we have x and 15. If we prime factorize 15, that is 5 into 3, right? Their HCF is, as per question, their HCF is 3. This means the common factor in both is 3, right? So we can say that 3 into a for time being, right? Now the second condition is x and 140 and their HCF is 14. X and 140. So what is the prime factorization of 140? For 0, it will be 2 into 5. For 14,
Yes.
it will be
And
7 into
2
2,
into 7.
right? So this will be 2 square into 5 into 7. So the HCF of these two is equal to 14 14 is 7 into 2, right? 7 into 2, right? Now, what this actually mean? Can anyone tell? Because there will be 3 in that, there will be 2 in that, and there will be 7 in that. But you can also see that there will be no 5 in that. One thing, 5 can never be included in that, and that cannot be a multiple of 4, right? Okay, now see, we have 660, right? So what is the prime factorization of 660? 66 into 10, 66 into 2 into 5. This is 6 into 11 into 2 into 5. This is 2 into 3 into 11 into 2 into 5. So this will be 2 square into 3 into 5 into 11, right? This is 660.
3.
Now for x, we saw that that will be some multiple of 3, 2, and 7, right? Okay, so what could be the HCF of these two?
33. Sorry, what did you say?
I'm saying what will be the HCF of these two? And
It's
some
Multiple of
multiple, right?
6. Multiple of
Yes,
6.
exactly. That will be 3 into 2 and some multiple, which we don't know about, right? So that must, first thing, that must be a multiple of 6. Now if we move to the options, the first option is 22, right? For 22, that is 2 into 11. Straightforwardly ignore that because there is no 6 in that. This is not possible. Again, this is 6
Not
into
possible.
5. But at first we saw that if there is 5 included in that case, the HCF will be greater than 3, not a 3, right? So this is also not included. In case of this is 3 into 11. But in our case, it's a multiple of 6, also not included. In case of 4, that is 2 square into 11. But we saw that this is also not possible that 4 is included in that. And the last option is E, which is 6 into 11. So this is a multiple of 6, in which the multiple is 11, multiple of 11, right?
Can you repeat?
Which part?
After the second one, I mean HCF of x and 140 equal to 14. After that,
Okay. Listen. Okay. You got till now, till 140?
yes.
Okay. So first of all, we have HCF 3. So x will be a multiple of 3, right? From second, we got that the HCF is 14. So this will be also be a multiple of 7 and 2. This means the x as a whole is a multiple of 3, 7 into 2, right? And let's suppose that that is a consider a as integer because we don't know about a right now. So for time being, we just know that x is having 42a, right? Okay. Now see, the question was asked that which of the following could be the HCF of x and 660, right? Now just prime factorize 660. That came out to be 2 square into 3 into 5 into 11. And x was 3 into 2 into 7 into some integer multiple. So first tell what will be the HCF of these two?
Three into 2.
3 into 2, some multiple of 3 into 2, because we don't know about a, right?
Okay.
Okay, so the HCF will be some multiple of 6. Let's consider this at 6a, right? Now just move to the options. First of all is 22, that is 2 into 11, not a multiple of 6, completely ignore this. Next one is 30, that is 6 into 5. But 5 cannot be possible because in first scenario, the HCF of x in 15 is 3. The factorization of 15 is 5 into 3. If 5 is included, the HCF is not 3, right? So this is also negated. The next one is 33, 3 into 11. This is not multiple of 6. The next one is 44, 4 into 11. This is also not a multiple of 6. And the last one is 66, 6 into 11. This is a possible multiple of 6. That's why the HCF of x and 660 is the possible HCF of x and 660 is 66. Got the point?
Yes, yes.
Okay, let's solve another question similar to this. The question states that HCF of 10 and x is equal to 5. HCF of, not HCF, LCM of 10 and x is equal to 30. The question is saying which of the following could be the possible value of 4x. I repeat the question. HCF of 10 and x is 5. LCM of 10 and x is 30. The question is saying which of the following could be the possible value of 4x. The options are 30, 60, 90, 120, and 240. Just take 2 minutes to solve this question.
B.
Yeah, 60.
16 B.
$60.
Yes, anyone who is still solving,
Yes, yes.
just solve this quickly.
It's 60.
Yes, it's 60. Okay, this is a very simple question. The question was that HCF of 10 and x is 5. We have x and 10. The prime factorization of 10 is 2 into 5. The HCF of 10 and x is 5. This means the x is having a multiple, is a multiple of 5, right? Now the next thing is the LCM of 10 and x is 30, right? Okay, so again 2 into 5. And if we prime factorize this, this is 2 into 5 into 3. This means this will also include 3, right? So the x from these two, the x must be a multiple of 15, right? Okay, let me add someone. So what exactly the question is asking? The question asks that which of the following could be the possible value of 4x? So x is a multiple of 15. So 4x will be equal to 60, some multiple of 60. But there is one more thing to see, that it can never be even multiple of 60. Because if this is even multiple of 60, the HCF of 10 and x will not be 5. So if we just see the options now, this is 60. That is not possible that 30 is the integer multiple of 60. And 60, yes, if multiple integer, that is 1. It is also not possible. In this case, it is multiplied with an even number. It is also not possible. And also in this case, it is a multiple of even number, which is also not possible. So only possible answer is 60. This was very basic question, very simple question.
It can be also solved using that formula you just told me. Like
Yes.
Yes.
is equal to HCF into LCM.
Multiply the number equal to LCM into ACM.
Yes.
This would be more easy, I think, to solve this problem.
Yes, you can solve both way. I just include this question because I just showed the old method which we use in the earlier question. Okay.
Yes, yes.
Okay. Now let's see how the question of LCM could be asked in exam. For example, let's take a very simple question. A wall clock alarms every 4 minutes. Whereas table clock alarms every 10 minutes. Right. A wall clock alarms every 4 minutes, while the table clock alarm every 10 minutes. The question says that if both of these alarm together at 10:15 a.m. of the morning, the question says which are the following would be the time okay, so again, the same invitation, the session is about to end. So just join the link again. We will proceed from where we left. Join the session again. Okay, which are the from where we will start from where we left. Look, we are writing the question that a wall clock alarms every 4 minutes, while the table clock alarms every 10 minutes. If both of these alarm together at 10:15 a.m. in the morning, which are the following would be the time when both of these clocks will alarm together again?
10:40, 10:55.
10:55.
10:35.
35, 10:35.
Let me write the option first. Because this is possible case, not
Yes.
the
10:30, 10:35.
okay, but a possible time when both alarm together. Right, so first option is 2:30 p.m. Other option is 4:45 p.m. Third option is 5:10 p.m. and fourth option is 6:35 p.m. and last option is 8:50 p.m. Now tell what will be the answer.
Option D, 6:35 p.m.
Yes, exactly.
Yes, 6:30 p.m.
This is a very basic question. I was just showing you the way how the LCM was actually LCM question was asked in the exam, right? Less like in the scenario, we have two clocks alarm at different interval, one alarm at 4 minutes and other alarm at every 10 minutes. So we just need to find the least multiple of those So that is 4 and 10. What is the LCM of these two?
20.
20. So these will be alarmed together every 20 minutes.
Yes.
So just see that 10, 15 plus 20, 35, 55, then 15, then 35, then 55. Now you can straightforward see that there is only 135. 30 is not possible. 45 is also not possible. This is not possible. This is not possible. Only this is possible answer.
Yes.
More or less, most of the question asking about the LCM are same. There could be like one train leaves the station every 10 minutes. The other train leave the station every 15 minutes. And the next train leave the station every 25 minutes. If they all of these leave the station early in the morning, let's suppose at 10 a.m. So what will be the time at which all of these will leave the station combined next time? So that is all again the same scenario, right?
Yes.
Okay, now if we talk about the HCF, let's suppose this is also a very basic question. Okay, sorry. The question is that Raman cut a rectangular board into identical scale pieces. Everyone, you are able to understand my writing, right? But I just write down.
Yes.
Okay, because I am writing for the first time using the tablet and it's a bit difficult for me to write. That's why my writing is a bit difficult to understand. Okay. The question was, Raman cut a rectangular board into identical square pieces. If board is 18 inch to 30 inch, what is the least number of square
Or
pieces?
did you write if boast? I didn't get it. If boast or something like that. You wrote
There.
if after it the word is what?
Raman
If.
cut a rectangular board into identical square pieces.
Okay.
If the
I
board
got you.
is 18 inch, this sign mean inch. Sorry, let me write the whole. 18 inch or 30 inch. What is the least number of square pieces he can cut without wasting any board? This is just application of HCF question. Just solve this question.
She
Simply use the concept of HCF here.
$15, right?
Okay, so one answer is 15. One
6.
answer is 6. Any other answer?
three.
6.
6. Okay, so 2 votes for 6. The answer to this question is 15. So I will repeat the question. The question was, Raman cut a rectangular board into identical square pieces. If the board is 18 inch to 30 inch, what is the least number of square pieces he can cut down without wasting any board, right? Okay, so first the thing is, as we are not wasting any material out of this, the length and width, right? One is length, one is width, must be divisible by the side of square which we are making. Actually, what is
Yes,
HCF,
90.
right? We have the factor that evenly divides both numbers, right? So if we try to visualize this, we have 18 and the other value is 30, right? First of all, what is the HCF of 18 and 30?
540.
3 square into 2. This is 3 into 2 into 5. So what is the HCF of this? HCF is 6, right?
Yes.
Yes,
HCF is 6.
6.
So for 18, 6, 6, 6, 6 and 6. For 30, 6, 12, 18, 24 and 6, 6, 6, 6 and 6. If you just combine these, so right, 3 into 5, 3 into 5, for 15 identical square pieces without any waste. The question was that Raman cut a rectangular board into identical square pieces. If the board is 18 inch to 30 inch, what is the least number of square pieces he can cut without wasting any board, right? So I was showing that
Yes.
if you take the LCM of 18 and 30, the LCM is what? 6, right? So 6 into 6 into 6, and these are 5. So total there are 15 identical square that could be made out of the rectangular piece without any wasting. Right?
Yes.
And the question says the least number of square. So that's why we take the highest common multiple, the highest common factor, to get a least number of square pieces out of that. Okay, so let me just show you the statement of another question. There was another question. I will just show the statement that bouquets are to be made using a white tulip and red tulip, and the ratio of the white tulip to red tulip is same in all of the bouquets, right? It means that I'm the okay. Next, that if there are 21 white and 91 red tulips available, what is the greatest number of bouquets that can be made without wasting any bouquet? So this is just another question with a similar statement. I was just showing you the way that how HCF or questions are asked in exam. Either the way which we did earlier by combining the HCF of some variable and number and LCM, that way or this way. More or less the question will be asked by this way, right? Okay, so anything is left with the HCF and
Your
LCM.
voice is coming to me after breaking down.
What you are saying?
You are not audible clearly. Your voice is breaking down. Your voice come to me after breaking down.
Still not audible, right?
No. Right now it's okay. It's okay right now.
It's clearly audible.
Okay, so this is a basic, just a basic introduction about the HCF and LCM. What is the time right now? Shall we proceed further? Okay, instead of proceeding further, let's solve. Let me give you one question from the old session just to assess whether you are preparing or whether you're understanding the things or not. The question is from the even and odd questions, right? Concept. Am I clear audible now, right?
Yes.
The question is that which of the following, and all of you must be able to solve this question now because we have discussed the even and odd a bit, explained in a depth, right? So question is which of the following integer can be written as both the sum of five consecutive odd integers and the sum of seven consecutive odd integers. I repeat the question that which of the following integer can be written as both the sum of five consecutive odd integers and the sum of seven consecutive odd integers. The options are 49, 70, 140, 215, and E is 525. Just take 2 minutes to solve this question. I will again repeat the question that which of the following integer can be written as both the sum of five consecutive odd integers and the sum of seven consecutive odd integers. The options are 49, 70, 140, 215, and 525. Just solve this now.
C. Acha, that is E. Sorry, not C. 525.
Okay, so one option answer is E. Any other answer? Is this a difficult question?
No.
This is a very basic, easy question as well. Anyone still solving or shall I solve now?
E.
Okay, so there is a integer that can be written as a sum of five consecutive odd or seven consecutive odd. First of all, let's see, we have five consecutive odds, right? There are two ways to write this. First one is odd, even, or even and odd, or even, odd, even, odd, and even.
Five consecutive odd integers you have written, no?
Both the sum of five consecutive odd integers. Okay. We have five consecutive odd, yes. Five consecutive odds and seven consecutive odds. So what is the result of these?
Odd.
Odd.
This is basically 5x and 7x.
Yeah. First of all, the thing is this will be odd. Second, we discussed that we have how to make the expression after this. Start from middle. If this is x, this will be x plus 2, this will be x plus 4, this is x minus 2, and this will be x minus 4. So what will be the answer? 5x, because we're adding these. And for the 7, likewise, plus 2, plus 4, plus 6, minus 2, minus 4, and minus 6. This will be 7y, right? So thing is that must be a multiple of 5, multiple of 7, and odd multiple, right? So just take the LCM of these two. That will be 35, some multiple of 35, but this is odd multiple. Just see the option 49. No. Next one
No.
is 70. that is even multiple, straightforward no. Next one is 140, that is also even multiple, no. Next one is 215. Is 215 is a multiple of 35?
No.
No.
No. And the last option is 525 and 525. And 525 is an odd multiple of 35.
Multiple of
35.
yes.
Right? Okay.